Hey students, it's me, Mr. Fitz, and some of you wanted me to make a video on outliers, and so here we go. Hopefully it'll be quick, and it wouldn't be a fun applied math video if I didn't add a little cartoon. This comes from, let me look that up, xkcd.com, and it is under the Creative Commons, so I'm free to copy it and use it as long as I don't make money off it. All right, here we go. Sorry. We're going to talk about outliers. And so here is an example of a couple of box plots, and we talked about these in class. And so it looks like, some of these data points out here could be outliers, right? And we talked about the skewness of this data, right? If the median is below the mean, then it's positively skewed, meaning there's some numbers out here that are dragging up the average. So let's take a look at how we actually calculate to see if these are in fact outliers. So what is an outlier? An outlier is an observation that lies outside the overall data pattern. And here are some examples. So for example, if I had this like scatter plot here, this looks like we could fit a line, like an upward sloping line here. It looks like it'd be positively correlated, the data, whatever this dependent variable and independent variable are here. And then you have a little outlier out here. It doesn't quite fit the data. For like a normal distribution, we haven't really talked too much about these in class, but here's a normal distribution. So 95% of our data fits within 2 standard deviations, and 99% of our data fits within 3 standard deviations, meaning all of these data points under this curve. So if you have something out here that's like 3 standard deviations away, or even something over here, that would be considered an outlier. Or if we're thinking about a box plot, an outlier would be like out here somewhere. So if this would be the minimum, quartile 1, median, quartile 2, quartile 3 I should say, and the maximum. Okay, so here's the data that we use to create those box plots. And this again is our interquartile range, and the interquartile range, that's the number I'm going to talk about a lot, is the distance between Q1 and Q3. So 50% of our data falls within this range here. So in this range here would be 33. How I got that is 37.75 minus the 4.75. And the interquartile range for this one is 10.75. So it's just this distance, 18.75 to 8. Like, what is that distance? How far is that? An outlier, for the simple way to calculate this, is we just look at what is 1.5 times away from the interquartile range. And so what I'm going to do is I'm going to take this number and multiply it by 1.5. If you were like thinking about like looking at this sort of data, generally we would use like 3 standard deviations is generally considered an outlier. So let's take a look at some calculations. So first off, what I want to do is calculate that interquartile range, and that's again the distance from 4.75 to 37.75, and in this case it would be 33. Then I'm going to multiply that by 1.5. So that's 49.5. And then what I'm going to do is figure out so almost 50. What is 50 away from this Q3, or 49.5 away from the Q3? And what is 49.5 away from the Q1 going this way? And those would be our outliers. So third step. So outlier on the negative side would be negative 44.75. Well, we can't have negative latenesses, right? So we can't be late negative times. So that's not no problem. And then 37.75 plus 49.5 is 87.25. So if somebody was late, say 88 times, that would be considered an outlier. So that's what I would call an outlier. But nobody was late that many times. We had 73. So let's take a look at this again on this box plot down here. If you want to pause the video and try it yourself, we did that in class. See if you can figure out if, say, this 46 is an outlier. Here we go. Yeah, so there are no outliers in this data. And then the interquartile range for this data, the absence data, is 10.75. So it's 18.75 minus 8. That's that distance there. So what is 10.75 times 1.5? 28.125. That's not right. Hold on. So that should be 16.125. Sorry about that. Let's go ahead and write that in. 16.125. Okay, so 16.125. So what is 8 minus 16.125? That would be like negative 8, right? Negative 8.125. So that's that number I got right over there. And then what is 16.125 plus 18.75? Well, that's 34.875. So any number greater than 34.875 is considered an outlier. So look, we do have data points actually out there. So let's take a look at that. What is that? Anything outside of this number here, this 34.175, all of this data would be outliers. So what I would do is I would actually erase this on my box and whisker plot and cap it off right here at the 34.875. And then I would mark these, any data points out here with like an open hole, like a donut, just like I did there. So you would still show the data, but it would just be an outlier. Here, I'm going to show you what that's going to look like. So this is a good way to kind of represent that. So we just kind of marked off with a dotted line, and then there's our outlier out here. And then there could be some other data points in here too that we could mark. So anyway, hope this helps. Please let me know if you have any questions, and thanks so much for watching.